Welcome to homework.
Hi everybody. So we gotta show the angular velocity of vector W of an asymmetric body under no force is absorbed from the body itself at a constant rate, which is the n I I n squared. Okay, that's what we want to show. And the image they kind of gave us is kind of wonky, but it's okay. So we have x, z with a little arrow here. Here we have G, we have W, and from here it's kind of free-handed. And from about here we have HG, and from these two we have theta. Okay. And so the angular velocity of a body is given to us as negative phi sine theta I plus phi cosine theta plus capital phi k hat. And so we need to do the angular acceleration of the body, which is gxyz plus the cross body product of that. That is 0. And if we do negative phi times sine theta I plus phi cosine theta k, cross body product of negative phi sine theta I plus theta phi cosine theta plus phi k, and we'll just do the cross body product of that. You will get phi sine theta j hat. Okay, and acceleration as in the body is represented with angular velocity. So what we have is another angular velocity, negative direction, which is L I hat plus M J hat plus N K hat W X I hat plus W Z K hat. And from this, we get M Z I hat plus N X J hat minus L W Z J hat minus M X K hat. And if we combine the two, this and this together, we have phi, capital Phi, sine theta j. That's negative, equals M W Z I hat plus N W X J hat minus L W Z J hat minus W X K hat. And so now if we have M Z is going to equal to 0, M is going to equal to 0. Okay? So if M equals 0, we can cancel that out. And so now we have phi, and I'm just going to, let's just box this here. So from here, we have phi, capital Phi, sine theta equals n w x j. And actually, all the j's are going to cancel out. So yeah, all j's cancel out here. This little hat here. X minus L z. Okay. And so we know what x. So what we're going to do is we know what x is. So I'm going to put it over here. So x is equal to negative phi sine theta. And z is equal to phi cosine theta plus capital Phi. And so we're just going to plug that in here. So we have phi. We've got the negative here. Capital Phi. And this is sine theta equals negative n phi sine theta minus L of phi cosine theta plus capital Phi. Let me get that capital Phi looking nice. Capital Phi. Okay, and if we have n equals phi and L equals 0, that's going to be gone. And we also have mx equals 0 and m equals 0. And from this, what we can do is, so we have negative phi sine theta equals phi theta sine theta. And now we just have to use our equation that we have for k. So now we're just going to use MO equals I z minus I phi cosine theta phi sine to the j hat. So that equals 0. And we have I z minus I theta cosine theta sine, phi sine theta j. Okay? And what we can do is, again, do I z equals negative I phi cosine theta. And we get theta, phi cosine theta equals I z over I. And but so what we're going to do is we have z is equal to phi plus phi cosine theta, which is what we said a second ago. This is actually going to equal to I z over I here. Or what we can say is z of I equals phi I plus I z. And what's more, we can say that phi I equals wz I minus I wz. And now your phi is going to equal to wz over I minus I over I. And now your phi is going to equal to n, and your z is going to equal to 2. So we have n equals I minus I over I of 2. And that's the answer, guys. Thank you.